Did you ever hear somebody say something like, "That's not science, that's science fiction," taking science fiction in a derogatory, negative way as something totally impossible? I have, but I want you to reconsider this idea. The spectrum of science to science fiction is not from the possible to the impossible. There's a more complementary relationship and synergies between science and science fiction I want to talk to you about today. Physicist and science fiction writer Gregory Benford has said that science fiction plays with the net up. That is, it doesn't contradict known science. And ideally, science fiction is a creative, imaginative speculation based on science, not contrary to science. Now, for the record, Star Wars is not science fiction. And even though I love it, Star Trek is not often science fiction in the Gregory Benford sense either. Now, I think the logical Mr. Spock, with his rich underlying emotions, is actually a pretty good role model. And Star Trek inspired my twin interests in science and science fiction from a very early age. So again, I love it, it's inspiring. Now, let's talk a little bit about science. And to start, we'll stand on the shoulders of some giants. Carl Sagan, like me, was an astronomer and a science fiction writer. His novel Contact got turned into a pretty good movie. He was also the host of the TV show Cosmos. And Cosmos often used science fictional elements in its mission to educate the public about science and astronomy. Carl Sagan also slipped some science fiction into his science. 1976, with Ed Salpeter, he wrote an article for the Astrophysical Journal supplement titled "Particles, Environments, and Possible Ecologies in the Jovian Atmosphere." He was writing about aliens from Jupiter, okay? He's my kind of guy. Now, he said that science is a way of thinking much more than it is a body of knowledge, and that's absolutely true. There's a misconception that science is a body of facts. But science is a methodology for developing reliable knowledge. In practice, scientists collect phenomenology, they make observations, they find patterns and relationships among those, and then they develop hypotheses that may explain what's going on in those relationships. And then they have to test those hypotheses and see if the hypothesis holds up or if it fails. So science is not about proving things true so much as disproving things, being skeptical. And we need to do that because human beings have confirmation bias. Human beings can't be trusted to solve problems just with common sense. Common sense is not always right. As powerful as that is on its own, there is another element that's perhaps even more crucial to doing science. Another giant, Albert Einstein, said, "Imagination is more important than knowledge." And he was totally correct. Science requires imagination. It's a creative endeavor. There is no book on my shelf that I can go to as a scientist, pull it down and open it up and see what's the next project I can do. What's the next hypothesis to test? What experiment can I do to test it? All of that requires imagination. And science fiction is the practice of applying imagination to science, asking questions like how, why, what if. So these speculations are a vital element of doing science. Another giant, Sir Isaac Newton. Newton was a genius who had the time, interest, and drive to address seemingly everyday phenomena like a falling apple and approach it and solve it mathematically, quantitatively, in a way that few have ever done before or since. Now, as imaginative and creative as that was, figuring out an equation for a gravitational force, a real insight and creative jump was recognizing that the moon, like the apple, is being pulled by gravity. Science fiction writer Douglas Adams said that flying is the art of falling and missing the Earth. Okay? That's an orbit. The moon is falling and missing the Earth. And an understanding of orbits and a mathematical understanding of gravity were essential ingredients to landing people on the moon. That happened in the 1960s, but before that happened, the idea of people going to the moon was science fiction. Science fiction writer Robert Heinlein scripted the 1950 movie Destination Moon. A lot of speculative elements in there, but all based in real science. He got a lot of things right. One thing he got wrong was thinking that it was going to require private industry, business, to go to the moon, when in reality it turned out to be nation states driven by national pride. So we should realize that science fiction is not a hard predictive science, but science fiction and science both require you have a lot of ideas, most of which are going to be wrong. That doesn't make them wrong or bad, it's just part of the process. So, flying cars. This was an idea that science fiction got wrong. We may still get them, but so far, if you want to see a flying car, you need to go see a Harry Potter movie. That's fantasy. Now, we do have flying telescopes, which is kind of cool. In my opinion, as an astronomer, that's cooler than flying cars. We've had dozens and dozens of telescopes flying in space. Perhaps most famous is the Hubble Space Telescope. So these telescopes are, in addition to being spacecraft, they're a form of time machine. It's a really science fictional concept, but when you think about it, when you look out into space, you're looking back in time because of the finite speed of light. You are seeing most distant things when the universe was younger. And we have looked back and seen the primordial fireball of creation that we call the Big Bang. The Big Bang, when it was first proposed, was not a popular idea. It could have been categorized, and was categorized by some as science fiction. But the important thing was it passed observational tests that its competitors, like the steady state model, failed to do. So our telescopes in space and on the ground are now discovering alien worlds, the kind we only previously saw on Star Trek. And the thing about our telescopes, they're powerful. They're generating great knowledge, but we discover these alien worlds through small wobbles in their star, in the eclipses we see of stars. And if we're very lucky in a few cases, we see tiny points of light orbiting stars. It's pretty abstract. We need science fiction. We need the imagination of space artists to bring these things to life, to help not just the public, but the scientists ourselves really understand what it is we're seeing. Now, there are not just alien worlds out there, but exotic star systems with things that are nothing like our own Milky Way. Here we have a stellar mass black hole in a binary star system. It's blazing accretion disk. It's relativistic jets shooting material out at close to light speed. These are real things out there, and our telescopes are not yet capable of taking a clear picture of them. But again, thanks to science fiction and the imagination of space artists, we can get a glimpse of what these things look like. And we can expand our horizons to a much greater extent than stellar mass black holes and consider supermassive black holes. At the centers of distant galaxies, we find supermassive black holes with as much as billions of times the mass of our own sun. And recently, this has been a very fertile ground for the cross-pollination of science and science fiction. On the right, we have Gargantua, a 100 million solar mass black hole featured in the movie Interstellar. This visualization was brought to life in part by the efforts of astrophysicists like Kip Thorne, applying general relativity and simulating the light paths in the extreme gravity of a supermassive black hole lets us see this edge-on accretion disk lensed around the backside into a halo, so that we see, in essence, this kind of ring of light around a black hole no matter which angle we view it from. And on the left, we see the science reality of a real observation. We see the black hole of M87 with some 6 to 7 billion times the mass of our own sun using the Event Horizon Telescope. This image, a sub-millimeter image, has been criticized because it's a little fuzzy. It's not sharp like the simulation seen in the Interstellar image. In reality, the image on the left is one of the highest resolution images that human beings have ever produced. The resolution element is approximately 25 micro arcseconds. A micro arcsecond is 1/millionth of an arcsecond, which is 1/60th of an arc minute, which is 1/60th of a degree. It's an incredibly tiny angle, and it's totally amazing technology that have led us as a species to make such an image. So science and science fiction together, and I hope that there are people like me, kids like I once was, watching movies like Interstellar that will be inspired to go into science. So I want to leave you with a couple of thoughts. Science requires speculation as much as skepticism, and science fiction can educate and inspire as well as entertain. So next time you hear somebody say something derogatory about science fiction, that's not science, that's science fiction, go ahead and embrace it, because science fiction is a crucial aspect of the imagination of science. Thank you.